R is a separate random variable, Q is a separate random variable, but if we divide the resistance all over the load, okay, we can actually achieve another random variable omega, which is known as the margin of safety, or simply the factor of safety. Okay, so that's how it works for these two random variables. So we mix them up. So take note that mixing R and Q will actually transform your original equation from R greater or equal to Q into an R over Q greater or equal to 1.0. Okay, so for a safe argument on R and Q, we need to be sure that the ratio must always be greater than 0, or else there is no margin of safety that is placed specifically for a certain uh, beta index. Okay, so we change the argument now from R and Q individually to R over Q. But it is more promising to use the natural logarithm values, or the natural logarithmic scale, because upon taking the log of these two expression here, left and right, we convert your value 1 to the log, or the natural logarithm of 1, which is 0. And therefore, the probability, the variable, or the variable of argument now will be changed from R over Q again to the logarithm, or the natural logarithm of R over Q. Okay, and the limit, instead of having a limit of 1.0, we have a limit of 0 here, and instead of having a sign of greater than, we make use of a less than to indicate failure. So we change the inequality, or the comparison, the Boolean inequality, the conditional inequality, from greater to less than, since it is more appropriate to talk about failure as an argument rather than margin of safety or survival as an argument. So, but you can do whatever variable of concern you want to use. No? So we're just trying to define here an argument on failure and a survival uh, uh, argument. Okay, so failure or safety. Okay, other word for survival is safety. Okay, it doesn't matter if you use failure or if you use safety, but most of the time we use this as your argument when we talk of probability. So the margin of safety is then measured in terms of the number of times the standard deviation sigma is to the mean of the logarithm, the natural logarithm of R over Q measured from the origin, and this is also referred to as the reliability index beta. So what is the reliability index beta? As we can look into the graph. So again, from the two separate bell curve that we used in our discussion a while ago, we actually transformed it in a single curve and define it in terms of logarithmic scales, and therefore define what is beta, because we have to understand what beta is all about. So beta is the number of times the mean of such an argument. What's your argument now? The argument, when I talk of argument, I simply mean the variable of concern. So my variable of concern now is the natural logarithm of R over Q. And from the mean of this curve representing such argument, ito yung average ng mga nakuha mong data from resistance, and Q. Okay, so when you try to make use of test procedures, you must be having different samples, no? Sufficiently enough to deal with such or to come up with such a good representation of the this curve, okay, this bell curve that you use in statistics. So beta is simply the multiples of such distances from, okay, from the origin up to this. Okay, when beta is small, when beta is small, then your failure, the probability of failure becomes big. Okay, so take a look that when beta is small, your margin of safety, or omega, is uh, small also. Okay, because your failure f is big, the area. Okay, while if your beta is big, then your margin of safety is factor of safety is big. Sorry, when your beta is big, your margin of safety is big, then your failure is small. Okay, so that's how things go. Okay, that's how things go when you compare your argument. Okay, so of course, naturally, when you want to make use of a reliability index, it's not good to make it so too big, no? So when beta is too big, then your failure will become very, very small, but your structure will be costly. So you have to dictate only a value of beta that is within the allowable guideline of imposed, no, by the codes on you, because we don't want to over design a structure just because we want failure not to happen. So it doesn't work like that, no. So we just want to make sure that your beta is enough for you to be able to give ample factor of safety to your structure. Okay, so let's go into the mathematics of the probability procedure. Okay, so this is not difficult, but it's quite confusing when you look into such notations. I just like to give you this presentation for you to be able to come up with a good understanding of how reliability analysis is all about, so that when you want to make use of reliability analysis on your study and on your projects, you can use the same procedure. No? So this has something to do with statistical analysis, or what you call the reliability analysis. So the probability of failure